Alright, hi everyone. So this is the second lesson for our topic 2, which is trigonometry. So up from the three lessons that we will have for trigonometry, I would say this is one of the most important one because this is the part where most of the question for trigonometry question come out in your past year questions. Alright, so let's look at the learning outcome. Okay, so in short, actually today you are going to learn two things. So the first one is actually called as compound angle formula. Okay, so which is what is stated here. You are going to learn what is the expansion for sine A plus B, A minus B, then cosine A plus B, A minus B, and tangent also. Okay, then the second one is called as double angle formula. So it's the same thing like what we have learned previously for all the trigonometry identities. So after you have learned the formula itself, you are going to use it to do some simplification or like expansion, or how do you use it to solve your equation and also your proving and so on. Okay, so those are the focus for our lesson today. Alright, so let's try to look at the first part, which is the compound angle formula. Okay, so let's start with compound angle formula. So, first thing, so what is that meant by compound angle? So, if A and B are any angles, so A plus B or A minus B is actually called as compound angle. Okay, so in this section, basically you are going to learn what is the expansion for sine A plus or minus B and cos A plus or minus B, and then tangent A plus or minus B. Okay, so I think the first thing very important for you is to recognize this. Let's say if I have sine A plus B, is it the same with sine A? Because like expansion, right? So is it the same with sine A plus sine B? Okay, so let's try to prove it. So let's say we have A equals to 30 and B is 60. So we know that if we have sine A plus B, meaning that sine 30 plus 60, right? So we will get sine 90. So sine 90 is a special angle which will give us 1. Okay, so the same thing, let's try to check if we are going to expand like this, what is the answer that we will get? So sine A, meaning sine 30, plus sine 60. So we will have 1 over 2 plus square root 3 over 2. So you are actually getting 1 plus square root 3 over 2. So from here, you can definitely see that 1 and 1 plus square root 3 over 2, they are definitely different things. So that's why sine A plus B is not equal to sine A plus sine B. So that's why we need to come up with the compound angle formula, so we know that how do we actually expand this expression. Okay, so now we will try to derive the compound angle by using the two triangle here. So as usual, the proving part is for your better understanding. So if you really can't understand, that's totally fine. What is more important is the application on the questions later. Alright, so let's try to look at the proving. Okay, so we will be doing our proving by using these two right angle triangle here. So to make the process like easier, maybe we can try to denote some variables to the triangle. Okay, so let's try to do this as O, P, R, and S. Okay, so you can see that you have two right angle triangle here. So the first one is OPR, the second one is ROS. Okay, so since we want to find A and B, right, and we want to find sine A plus B, so that's why we'll try to use the angle here. Okay, so we try to denote this as A and this is B. So we want to find out what is the expansion for sine A plus B. And we will set our triangle OPR to have a hypotenuse of 1. Okay, so this is like the basic setting of our proving. Okay, so we will start now. Okay, let's say if you we are looking at the triangle one by one. So we have now the diagram over here already. So we will start with the triangle for OPR. So we are going to just use your basic knowledge of sine cos tangent to do that. Okay, so for the triangle OPR, let us find out what is the length for OR and O and PR by using SOHCAHTOA. Okay, so since we already know that OP is 1, right? So let's start with the sine first maybe. Okay, so sine B. So this is the right angle triangle. So sine OH, right? So that's why sine B is going to be PR over 1. So in the other word, we know that the length of PR is sine B. Okay? So after you have write, then you can write down here as well. Okay? So now, go to the other one. Let's try to do cos. Okay, cos B. So for this triangle as well, so cos meaning that AH, so that's why OR over 1. So I have OR equals to cos B. Alright, so we know that for the part here is going to be cos B. Okay, so now let's move on to the other triangle. In triangle ROS. Okay. You now might feel very confusing, but it's totally fine. So I'm trying to start from the easier part so you don't get confused that much at first. Okay, so ROS. So can we try to do the same thing? So now you know that the hypotenuse is cos B, right? So let us try to find the opposite part and the adjacent part. So let's try to do sine first. So sine A. Okay, so sine A, OH. So what is our O? Is RS. Then our H we know already, which is cos B. So what is the length for RS? RS is going to be sine A cos B. Okay, just move it. Okay, then the same thing, let's try to do cos. So for cos A, I have A over H. So that's why OS over cos B. So what is OS? OS will be equals to cos A times cos B. Okay, same thing, let us just write down what we have got here. So RS is sine A cos B. So this part is going to be sine A cos B. And then for OS, OS is equals to cos A cos B, right? So let us write down cos A cos B. Okay, so we have completed for the first part. So now you see, what we are finding now is sine A plus B, right? So the idea of A and B here is I can combine these two angles together and it become one compound angle. So if I were to find the sine for A plus B here, meaning that I must have one right angle triangle for these two angle as well. So where can I actually create one right angle triangle for the angle A plus B? Then what I can do is I will try to come out the other right angle triangle here. So you can see that now I have a new right angle triangle, which I have one of the angle here is A plus B. And after that, I want to find out what is the opposite since I already know that the hypotenuse is 1. So how can we get to the opposite? So by looking at this length, right, just now we already find RS. So we know that this length here is going to be RS as well. But how about the part here? So what we can try to do, same thing, create another right angle triangle again. So here. Okay, so now we have these two new right angle triangle. Okay, let's try to write down what is the angle that we have. Okay, so let us just quickly put in the right angle over here. So you know that this thing is going to be like a rectangle as well. All right. Okay. So our target now is actually to find out what is the length for PB. So we know that the length here is going to be the exactly the same with RS. So let us try to just denote the other variable. So to help us to find the length for PT. Okay, so how can we find that? So since we already know that this is a right angle triangle, right? So let us try to do like this. So you can see this is the right angle triangle that we have previously. And if this is A and this is 90 degree, then what is this? So this is going to be 180 minus 90 and minus A, correct? So this one you will get 90 minus A. Okay, 180 minus 90, you get 90. So 90 minus A, which is this angle. So since this angle will be the same, so that's why this is 90 minus A as well. So when we try to look at this triangle, this is a right angle triangle, right, over here. So if this is 90 degree and this is 90 degree minus A, then what is this? This is actually A. Okay, I hope that I can get that. Yeah, so this is like 90 degree minus A, 90 degree minus A, so 90 degree, 90 degree. So this one A, so this one should be an A also. Yeah, because they are the same, which is the right angle triangle. Okay, now with this angle, then we can try to find out the other side now. Okay, so same thing. Now we are looking at the triangle for PTR. Okay, so same thing. Let's start with sine. So what is sine A? So the sine A here will be equals to my opposite and then my hypotenuse. So that's why my opposite is TR. My hypotenuse is what I have already, which is sine B. Okay, so from here I will get what is my TR or RT, which is going to be sine A and sine A, sine B. Okay, same thing. So let us just write down here. So this is for TR or RT. So this is sine A, sine B. So now let's try to find out for PT. So cos A. So the adjacent part will be your PT and over your hypotenuse, which is sine B. So what is PT? PT will be equals to cos A, sine B. Okay, so PT here is cos A sine B. All right. Okay, now we have the length that we want already, right? Okay, now let us continue to get the compound angle now. Okay, so let's start with sine first. Okay, sine A plus B. Okay, so we are looking at this triangle now. So if you are finding sine A plus B for the angle A plus B here, the opposite will be actually equals to PQ, correct? So I'm just writing down everything so you can just understand it better. So PQ over your hypotenuse, which is OP. So how do you actually get PQ? The PQ here is you need to use your QT and then plus TP, correct? So QT plus PT. And then your OP, we already know that the hypotenuse is 1. So how do we get QT? So QT, the length here is the same with RS. So that's why it's going to be sine A cos B. And then what is PT? So PT is the length that we got just now, which is here, which is cos A sine B. So here we will have our first compound angle formula, which is sine A plus B. When you expand it, you will actually get sine A cos B plus cos A sine B. Okay, so let's try to do the other one for if let's say, okay, let me try to just finish the cos part first maybe. So for cos, right, same thing, cos A plus B will be equals to what? So we are looking at the big triangle here as well, because we are looking at a plus b also. So for you to find cos, then it will be adjacent over hypotenuse, right? So what's your adjacent? Your adjacent here will be from O to Q, and then divide by OP. So what is your OQ? How do you find your OQ? We only have OS here, which is cos A, cos B. But how can we get OQ? So you can see that you have TR here. So actually what I can do is I can use OS to minus the length of TR, then I'll get OQ, right? OS minus TR, so I will get OS. Then divide by my OP is 1 again. So equal to, what is my OS? OS is cos A, cos B. And then TR is sine A, sine B. So here I get the second formula for the compound angle, which is cos A plus B equals to cos A cos B minus sine A sine B. Okay, so you can recall just now we said that compound angle, except we are talking about addition, we also talk about minus. So we are not going to redo the whole thing for us to find A minus B, but we'll just derive from the formula that we got here. Okay, so what we are trying to do is for sine A minus B, we try to assume that you have an angle that actually the B is a negative one. Okay, so what we try to do is we just substitute and change all the B that we have inside the formula to become negative. Okay, so you can try to imagine like this B is an acute angle, right? From our proving just now. So if B is an acute angle, negative B should be in fourth quadrant. So in fourth quadrant, cos will give you what? A positive, right? So that's why the cos is still going to be a positive. Okay, the second one, you have sine negative B. So imagine same thing, negative B is in fourth quadrant. So fourth quadrant sine will give you a negative. So that's why this sign should be changed to negative. It's actually plus minus lah. So that's why plus minus become minus. So cos A sine B. So here you get the second formula, which is sine A minus B will actually give you sine A cos B minus cos A sine B. So the difference for sine is actually very easy to remember. They have the same term when you expand, which is sine A cos B, cos A sine B. But when you plus it, then you have plus. If you minus, then you have a minus. Okay, so you get the two formula here. Okay, now let's look at cos. So the same thing, cos A minus B will be equals to cos A plus a negative B. Okay, so this one you were getting equal to, so let's try to change all the B to be negative as well. So cos A cos negative B plus sine A sine negative B. Okay, so same thing just now. Negative B fourth quadrant cos give you positive, so that's why cos A cos B. And then plus, it should be minus because fourth quadrant sine give you negative, so that's why minus sine A sine B. Okay, do I do something wrong? Yes, this is this is minus. So that's why minus minus, this one become plus. Okay, so you have the second compound angle formula for cos, which is A minus B. Then you can see they have the same term, but when you compare to sine, it's the opposite thing. So if you have A plus B, then you are having minus. If you are having A minus B, you are having plus. Okay, so now we got these two formula already. Let's try to go with our very last one, which is tangent. Okay, so for tangent, right, if you can recall, we said that tangent A plus B will actually equals to sine A plus B over cos A plus B, correct? Because sine over cos, you get tangent. So that's why we can just put in everything that we have found just now. So sine A plus B is sine A cos B plus cos A sine B. Okay, divide by what is cos A plus B is cos A cos B minus sine A sine B. Okay, just here what we have got just now. Okay, so now how can we simplify this? Yeah, so this is the thing that might be a little bit tricky here. Okay, so what we are actually trying to do here is we want to let our expression only have tangent. So since we already know that sine over cos will give us tangent, right? So that's why we try to divide the whole expression here with cos A cos B. So meaning that I'm trying to do this over cos A cos B. Same thing for the other one, cos A sine B. I'm going to divide also for cos A cos B. Divide by the whole thing. Do the same thing, cos A cos B. Divide by cos A cos B. Minus sine A sine B. Divide by cos A cos B. So what do you have here? So you can see sine A cos B, cos A cos B. So cancel, you left with sine A over cos A, which gives you tangent A. Plus, same thing, cos A, cancel, then you have sine B over cos B, which give you tangent B. So you can realize that the whole term here is the same. So that's why you left with 1. And then after that, next, it's going to be sine A sine B over cos A cos B. So what do you left here? You can't cancel anything. So that's why sine A cos A will give you tangent. So tangent A, then after that tangent B. So we get our first compound formula for tangent A plus B, which is tangent A plus B is actually equals to tangent A plus tangent B over 1 minus tangent A tangent B. Okay, so let's try to do the same thing for the very last one. Yeah, I know this one is very long. Okay, so tangent A minus B. Okay, so I do think that we do not need to repeat the whole thing again, so we can try to use the idea of like negative B just now. If you want, you can repeat the whole thing by using A minus B lah, then you redo the whole thing, you'll get the exactly same thing. So tangent A minus, plus negative B. Okay, so you will have tangent A plus tangent negative B, and then over 1 minus tangent A, and then tangent negative B. So we are talking about the same B, right? So B acute angle, so negative B is in 4th quadrant, so that's why tangent for 4th quadrant will give you a negative. So this should become tangent A minus tangent B, and then over, so since this become negative, so negative become positive, so 1 plus tangent A tangent B. So you get the last compound angle here, which is tangent A minus B. Okay, so a quick one for what we have got just now, the 6th formula. So the first one for sine A plus B is equals to sine A cos B plus cos A sine B. Okay, so this is the first formula. So for A minus sine A minus B, then you have sine A cos B minus cos A sine B. For cos, you have cos A plus B equals to cos A cos B minus sine A sine B. For cos A minus B, you have cos A cos B plus sine A sine B. Then after that, for tangent, then you have tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A tangent B. So the last one is tangent A minus B gives you tangent A minus tangent B, and then divide by 1 plus tangent A tangent B. Okay, so but yeah, I mean, don't worry, this formula all will be given in your formula sheet in your exam. So later I'll be showing you how is that look like, and we are going to continue to apply it in the questions. Okay, so this is how the formula will be given in your exam. So basically, they actually already combine the plus and minus together. So I'm just going to teach you how to read that. So you can see there are two signs here. So sometimes you see that the plus is at the top, then after that the minus is at the bottom, or like the minus is at the bottom, the top and the plus is at the bottom. So the idea is that it depends on which one you want. So if you want sine A plus B, meaning that you are reading the top one. So meaning sine A plus B, then you need to write plus. So if sine A minus B, then you are going to use minus. So if cos A plus B, then you are going to use minus. So cos A plus B equals to cos A cos B minus sine A sine B. So cos A minus B give you cos A cos B plus sine A sine B. So if you are using the top one, then meaning that you need to take all the symbol for the top. If you are using the bottom one, then you need to take the symbol for all the bottom. Okay, as simple as that. Okay, so now let's look at the for example. Okay, question 1. Without using calculator, find the exact value of A sine 105. So for 105, when you see the word without using calculator, you should be able to relate to special angle. But 105 is not a special angle. So how can we find out two values that can make up 105, which is a special angle? So sine 105, we can always change it into sine 45 plus 60. Right? So this is how we can get 105. Okay, so now let us expand by using the compound angle that we have just now. So you will have sine 45, which is your A, then cos B 60, plus also then cos A, which is 45, and sine B, which is 60. Okay, then after that you have all this value, that means that you can find out your value for the for the special angle already. So sine 45 will give you square root 2 over 2, cos 60 1 over 2, and then plus cos 45 another square root 2 over 2, then sine 60, which is square root 3 over 2. Okay, so now you can just calculate it. So square root 2 over 4, and then plus square root 6 over 4. So when you plus them together, then you can get square root 2 plus square root 6 over 4. Okay, so you have nothing that you can simplify already, so that would be your last answer. So I mean, of course, in the process itself, you cannot use calculator to solve it, but as you got the answer, then you can just use your calculator to help you to check and see whether you got it correct or not. So like for example here, then you can, after you finish all, then you can try to just check sine 105. So you can see you get the exact same answer, so you know that your answer is correct. Okay, so same thing, let's go to B. So B, they want you to solve for cos 42, cos 12, and then sine 42 and sine 12. Okay, so same thing, if you are using your calculator, then if you can't use your calculator, so you should have special angle, but 42 and 12 is not special angle. So how can we combine them together? So you can see cos A, cos B, plus sine A, sine B. So how can we simplify this by using the compound angle here? So you can see cos, cos, sine, sine. This is sine, cos, sine, cos, sine. So of course you cannot use sine already. So you need to use cos. So this is plus. So plus is the one that align with minus. So that's why you can always change to cos 42 minus 12. So from here, you will get cos 30. Okay, so what is cos 30? It's square root 3 over 2. So the same thing, you can try to use your calculator to help you to just check here also. So you just type in the whole thing lah. So cos 42, sorry, cos 42 multiply with cos 12, yeah, cos 12, and then plus sine 42 multiply with sine 12. Okay, and check whether you get the answer or not. So 0.866, they didn't write it in the form, then maybe you can just check it out. 0.866, so square root 3 divided by 2. So do you get 0.866? Yeah, so which is correct. Alright, so let's move on to number 2. Okay, so number 2, given sine A is 4 over 5, cos B is 5 over 13, A is obtuse, B is acute, so find all the following value. Okay, so I think looking at this question, you should know that, you have learned this in your Pure Max 1 as well, trigonometry. So except the part that which you need to find like sine A plus B, cos A minus B, and so on. Okay, but it's going to be the exact same thing. So what we can try to do is, since you want to get sine, cos, tangent, right? So let us just find out everything in one shot first. So you already know that sine A is 4 over 5. So let us just try to draw a triangle for it. Okay, so you have A, and then your opposite is 4. Your hypotenuse is 5. So you should know that your adjacent is 3. So A is obtuse, so meaning A is in quadrant 2. So for quadrant 2, then later you remember when you do your cos and tangent, it must be in negative lah. Yeah. So A in quadrant 2. So that's why your sine A is going to be 4 over 5. And then cos A is A over H, right? So A is 3 over 5, but quadrant 2, so that's why negative. Okay, so same thing, tangent A, so OA, so OA, so negative as well. Okay, so same thing, let's try to do for the B. So same, you can just draw a triangle. So cos B, meaning that your A is 5, your hypotenuse is 12, so it should be 12 here. Alright, so since B is acute, so meaning B is in quadrant 1. So quadrant 1, then do not need to worry because all your sine, cos, tangent is positive. So sine B will become OH, so 12 over 13. Cos B is A over H, so 5 over 13. Then after that, you have tangent, which will give you OA, so O over A. Okay, so after you have get everything, then now we can continue with our ABC. Okay, so A sine A plus B. So same thing, we will use the formula to just expand it. So sine A plus B, when you expand it, then you should have sine A cos B plus cos A sine B. So you just substitute the value that you have get. So sine A is 4 over 5, cos B is 5 over 13, cos A negative 3 over 5, sine B 12 over 13. Okay, so after substitute, then just use your calculator. You should able to get 16 over 65. Okay, move on to B. So B is cos A minus B. So cos A minus B, when you try to expand it, you should able to get cos A cos B, and then plus sine A sine B. Okay, remember in your cos, so when you minus, then you have plus. So that's why cos A cos B plus sine A sine B. So same substitution. So cos A negative 3 over 5, cos B 5 over 13, sine A 4 over 5, sine B 12 over 13. Okay, so you can just calculate it, 33 over 65. Okay, move on to C. So C is tangent A minus B. So what is the formula when you try to expand this? Yeah, so you will have tangent A minus tangent B Then after that, divide by 1. So don't forget when you have minus here, so the top will follow the minus, but the bottom will be plus. So minus, minus, plus. Okay? So that's why 1 plus tangent A multiplied by tangent B. So substitution. So tangent A is negative 4 over 5 minus tangent B 12 over 5 and over the two things multiply. So negative 4 over 5 and then 12 over 5. So same thing, you can just press in your calculator. You should get 56 over 33. Okay, so that's it for this part. Let's go to next one. Okay, number 3. So solve the equation for x greater than 0 and smaller than 360. So this is basically solving a trigonometry equation lah. Okay, so is the same thing. So you can realize that actually all this question is just about how do you actually use the formula and change it, expand it, and so on. Okay, so sine 60 minus x. So 60 minus x, then meaning that your 60 is your A, then your x will be your B. So that's why when we expand it, then we will have sine 60 cos x. Okay, then after that minus, then it will be minus also cos your A 60. Then after that sine your B, which is x. So equal to 2 sine x, which you do not have anything to substitute that. Okay, so you can just continue. So sine 60 is a special angle that you can straight away get the value, which is square root 3 over 2. And cos x, so cos 60 is a special value as well, which is 1 over 2, then sine x. So which gives you 2 sine x also. So we can try to eliminate all the denominator by multiply the whole equation by 2. So now we can, when you try to look at this equation, right, you can see that you have one cos and one sine, which you actually cannot do any factorization. But what we can try to do is, let's try to just group them together. So you have 1 square root 3 cos x and equals to, move this over here, then you have 5 sine x. Okay, so you don't have anything to solve. I mean, you can't do any factorization, but there is one relationship that tell you that tangent equals to sine over cos. So that's why you can just move over the cos and move over the number. So square root 3 over 5. Okay, so sine x over cos x. So sine x over cos x will give you tangent x equals to square root 3 over 5. So you can just use your calculator to get your reference angle, which you will get tangent 19.1. So tangent positive, first quadrant and third quadrant. So that's why x will be equals to 19.1. And the other one is the third quadrant, meaning 180 plus 19.1. Okay, which will give you your last answer, 19.1 and also 199.1. Alright, so that's the first questions. So if you want to check it, then you can always substitute back into your formula as well. So let's say you have the answer ready, right? So you can just 2, then after that, y2, sine 60 minus, so 19.1, right? So 19.1 in three significant figure. Your answer is going to be a little bit different, but that's fine. So 0.64654. So you can do the same thing. So 2 sine 19.1 and check whether your left and right is the same or not. So yeah, 6.654 also. So which you know that your answer is correct. Then you can check it again with 199.1. Okay, so let's try to see the second B here. Okay, so B, 2 tangent x equals to 3 tangent 45 minus x. So when you look at this question, it's the same thing, it's just about substitution. So 2 tangent x equals to 3. So tangent 45 minus x, so you can expand it by using the formula here. So tangent 45, meaning 45 is your A and x is your B. So tangent 45 So this is minus, so that's why top also minus. Then after that, 1 plus tangent 45 and tangent x. Okay, so now you can just try to find out the value for tangent 45. So tangent 45, you are getting 1. So that's why you can straight away just do your, what is that called, your expansion also. So 3 times 1, you are getting 3, and minus 3 tangent x. And then divide by tangent 45 is 1, right? So that's why 1 plus tangent x. So you need to make a quadratic equation here. So 2 tangent x and then plus 2 tangent square x. Okay, so 2 tangent x times 1, you get 2 tangent x. 2 tangent x times tangent x give you 2 tangent square x. And then equal to 3 minus 3 tangent x. So let us try to rearrange it. So 2 tangent square x plus 5 tangent x minus 3. Okay, so you should use your quadratic equation, your factorization. So if you think that is very confusing for you, then what you can try to do is you can try to let y equals to tangent x. But if you can do that in this form, then you can just carry it with this. So meaning that you can straight away 2 tangent x minus 1, I think. Then yeah, tangent x plus 3. Okay, so you are getting 6 minus, yeah, which is correct. So equals to 0. So what is your tangent? Your tangent x, the first one will be equals to 1 over 2. Then the second one will be equals to negative 3. So just find out the reference angle. So you will get tangent 26.6 here in 3 significant figure. Then equals to negative tangent. Actually, it's better that you write two decimal. Okay, and let's just write 4 significant figure first. 5, 7, and then after that equals to negative tangent 71.57. Okay, so tangent positive quadrant 1 and 3. So I do not write the what is that called, the working anymore. So I'm just going to just write the answer. So third quadrant meaning 180 plus, so I should get 206.57. Okay, so same thing for here. So x negative tangent negative, so it should be quadrant 2 and 4. So that's why 180 minus, which give you 108.43. Then the other one is 360 to minus, then you get 888.43. Okay, so you can just write down your answer, arrange them in a order 108.43 and then 206.57 and the last one 288.43. Okay, so after you can get your answer, you can always use your calculator to check it again lah. Just substitute your value in the x here and the x here. Then if you get two sides the same, meaning that you are getting the correct answer. Okay, so let's move on to the very last questions. Number 4, prove the identities. So let us start with the left hand side. Okay, so we should have 2 sine x minus y over cos x minus y minus cos x plus y. Alright, so I think you definitely can see that you need to expand all three of them. So that's why 2. So you have sine x cos y and then minus cos x sine y. Okay, whole thing divide by cos x minus y, which is cos x cos y plus sine x sine y. And then minus, so remember to put your bracket so that you won't confuse later. So cos x cos y, and then this is plus, right? So it become minus. Okay, so now let us see what is the thing that you can simplify. So at the top here, you do not have anything that you can add. So what you can do is just expand them. So for the bottom part, you can realize that you have 2 cos x cos y. So this part and this part, they can cancel out each other, and minus minus give you plus. So that's why you left with 2 sine x cos, sorry, 2 sine x sine y. So from the part which you need to prove, right, you can see that cotangent is like cos over sine, cos over sine. So you have two terms here. So here you only have one term. So you can imagine that what you need to do is you need to separate them into two. So 2 sine x cos y divide by 2 sine x sine y. Then same thing, minus 2 cos x sine y divide by 2 sine x sine y. So 2 and 2 cancel out each other, sine and sine, and then you left with cos y over sine y. So for this part also, cancel, 2, 2, then you left with cos x sine x. Okay, so cos and sine give you cotangent, and after that cos and sine give you cotangent. Okay, so I want to just repeat again, when you do proving, right, please try not to skip the step. I know that obviously you can see that this part cancel, then you can see cos over sine give you cotangent, then after that sine over sine, then you left with cos x over sine x give you cotangent. But then you need to show the part where you know that cotangent is from cos and sine. So try to do it like step by step. So I mean, in the mark scheme itself, sometimes it can get like a little bit like very strict on the part that how do you show your step clearly. Okay, so that's it for the compound formula part. So let us compound angle formula. So let us try to go to the part for double angle formula. Okay, so let's try to look at the second part, which is double angle formula. So, don't worry, it's not going to be a very long proving part for this part. Okay, so when we talk about double angle formula, meaning that we are getting like cos 2a, sine 2a, tangent 2a. So how are we going to prove it? We actually use the compound angle formula that we have learned just now to derive these three new formula. So what we try to do here is we try to consider that the angle that we have, meaning the a plus b just now, a and b are actually the same. So a equals to b. So now let's say if we have sine a plus b equals to this one, this is a formula that we have learned just now, and a equals to b now. So meaning that we can always have a plus a, right? Because b is equals to a. So it will be equals to sine a cos a, and then after that plus cos a sine a. So you can see that the part here, the two term here, is the same thing. So it's the same thing when we say 2 times 3 and 3 times 2. So that's why you can combine them together. So the first identity that we have is cos 2a will equals to 2 sine a cos a. Okay, because you plus them together, or if you write, then you can write down one more, just change this to sine a cos a lah. Then you can see this like much more clearer. So sine a cos a plus sine a cos a give you 2 sine a cos a. Okay, so simple as that. So we got our first formula. So let's try to go to the second one. So cos a plus b. So same thing, a and b is the same. So cos a plus a. So what do we have? Then we have cos a times cos a minus sine a times sine a. So when we combine them together, you can get the first one, which is cos square a minus sine square a. Okay, so this is the first one that you can have. Second one, let us try to change this by using the basic identity that we have learned. So cos square a minus sine square a is equals to what? 1 minus cos square a. Okay, so for this part, what can you get? So you can see cos square a plus, so yeah, I'm writing like this so you won't get confused. So this is the second one. Okay, so this is the first one that we have, which will consist of sine and cos. So now if let us continue to do that, what it will be looking like. So 1 minus cos square A. So cos square A minus minus, so you get plus. So that's why you will have 2 cos square A and then minus A. So this is my second formula, which consisted of only cos. So now let's try to do one more for sine. Okay, so instead of substituting for the sine part, we substitute for the cos part. So cos will actually equals to 1 minus sine square A, right? Then after that minus sine square A. So meaning that I'm changing the part for the cos square A here to become 1 minus sine square A. So what do you get? 1 minus, so minus minus, you get minus 2 sine square A. Okay, so for cos 2A is actually a little bit special if you compare to sine 2A. So you will have three formula here, which one to use is depends on the question, which one do you think is the most suitable. So the first one is cos square A minus sine square A. The second one is 2 cos square A minus 1. The last one is 1 minus 2 sine square A. Okay, so depends on which one is more suitable in the question, then you can change to either one, they are the same. Okay, let's try to look at the last one, tangent. So same thing, tangent A plus A. So I'll have tangent A plus tangent A. Then after that, divide by 1 minus tangent A times tangent A. Okay, so this one I think is quite easy to simplify. So tangent A plus tangent A, you have 2 tangent A, and then divide by 1 minus tangent A multiply tangent A, you get tangent square A. So this is the formula for tangent to A. Okay, so that's the part for the double angle formula. So in your exam paper, it will be given in this form as well. So they will give you the 3 different form for cos 2A as well. Okay, so let's try to look at the 3 very last questions. Okay, number 5, given that sine x equals to negative 3 over 5 and x is between 180 to 270, find the exact value of the below term. Okay, so the same thing, what we can try to do is use the triangle to find out the sine cos tangent first. So you have x. So sine is OH. So OH then your A. So x is between the range. So that's why you know that x will be in quadrant 3. So in quadrant 3, only tangent positive. So sine x equals to negative 3 over 5. Then your cos will be equals to A over H. Then after that, tangent O over A. So O over A. So don't forget your negative for cos. Okay, so after you have get this, then we can continue. So A sine 2x. So one thing that very important is please do not do sine 2x equals to 2 sine x, okay? So they are totally different thing. You can try your calculator and see whether sine 60 and 2 sine 30 is the same or not. It's totally different thing. So please don't do that. So what is sine 2x? So use your formula. So sine 2x is equals to 2 sine x cos x. Okay, then now you can just substitute. So 2 sine x is negative 3 over 5. Cos x negative 4 over 5. So by using calculator, you can get 25 over 25. 24 over 25. Okay, move on to B. So cos 2x. So since it's in this question, you have basically everything already. So that's why it doesn't matter that which one to use. But if you want, you can try it out also. I mean, for that 3, you are definitely getting the exact same answer. Okay, so let us just use the first one. So cos square x minus sine square x. So cos x square, that meaning that you need to do negative 4 over 5 square minus cos x, so negative 3 over 5 square as well. So same thing, calculator 7 over 25. Okay, so move on to the last one. Okay, so this is the difficult one. So tangent x over 2. So what you can realize here is in the formula itself, we have only 2a and a also. So meaning that if we change it to x, then it can be 2x and x. So how can we actually make another formula which is x over 2? So what you can realize here is this is double angle, right? So what is the relationship between 2a and a? 2a is the double of a. So if we try to set it in an opposite way, then it will be a is half of 2a. So meaning I can always change my formula into tangent a equals to 2 tangent a over 2, because this is how I get a from 2a, right? Divide by 2. So the same thing, divide 1 minus tangent square a over 2. So if you write a over 2, then this must be a lah, because this angle must be double of a over 2, which is a over 2 times 2 give you a. So that's why we can try to use this formula to help us to get the answer. Okay, so let us write down the formula first. So we can't straight away get to this answer. So meaning that what do we need to do equals to what? So tangent x equals to 2 tangent x over 2. The same thing like what I have done at the top there. Square x over 2. Okay, so since we want to get tangent x over 2, right? So this question already give us tangent x. So we can straight away get the value here, which is 3 over 4. So 3 over 4 equals to 2 tangent x over 2 over 1 minus tangent square x over 2. So what you can try to do, cross multiplication. 3 minus 3 tangent square x over 2 equals to 8 tangent x over 2. Okay, rearrange the whole thing in a good quadratic form. Minus 2. Okay, so same thing, if you think that it's very hard for you to deal with this, then what you can try to do, you just do let y equals to tangent x over 2 also can. Okay, so it's the same thing lah, depends on you. I think this question is okay if you try to do that, because what you want to solve is just tangent x over 2. You do not need to get what is your x, right? So that's why maybe you can just let y be tangent x over 2. So you can just change the whole thing. 3y squared plus 8y minus 2 equals to 0. Then you can try to do factorization. So you get 3y minus 1, I guess, then y plus 1, 2, y plus... do I do anything wrong? Yeah, sorry, this is 3. Okay, so this is 3. So that's y 1, 3. Yeah, then this is correct. Okay, equals to 0. So that's why that meaning that I will have my y equals to 1 over 3, and the other one is y equals to negative 3. So meaning that tangent x over 2 is 1 over 3, and the other one is tangent x over 2 is negative 3. So can you try to identify that which one is correct? So I mean, in this question, your range is only between 180 to 270. So it's quite impossible that you have both positive and negative for a tangent value. So what we can try to do is x is in between 180 and 270, right? So now we are fighting for x per 2. So that's why we can always change it to 90 to 135. So divide by 2, divide by 2. So we know that x over 2 should be in quadrant 2, right? 90 to 135. So in quadrant 2, your tangent should be a negative. So that's why you can write x over 2 is in quadrant 2. Okay, so that's why you should take the number that tangent x over 2 give you a negative value. Okay, so this is how you get the answer. Okay, number 6, solve the following equation. So the same thing, you just use your formula to help you to actually substitute the one that you can't solve. So the idea is you have cos 2x and sin x, which is like cannot, like impossible for you to solve that. So you must change your cos 2x to another term. So cos 2x plus 3 sine x equals to 2. Okay, so since you have three choices here, so which is the one that is more suitable for this question? So you can see that you have the term where 3 sine x here. So that's why you can imagine if you are using the first two, right, that meaning that you are having a equation that you have cos and sine together, then later you need to try to substitute it with another term again. So that's why the easiest way for this one is to substitute cos 2x with 1 minus 2 sine square x. Okay, so this is the idea for which one do you choose. Okay, so same thing, just quadratic. Plus 1 gives you 0. So by solving the quadratic, then you have 2 sine x minus 1 and sine x minus 1. Okay, so you have sine x equals to 1 over 2. The other one is sine x equals to 1. Alright, so you can just use your calculator. So you should be able to get sine. So since the question give you in pi, so that's why we try to write our answer in pi as well. So it should be sine pi over 1 to 30, so 6. Okay, so for sine, so what is the value that you have 1 when you draw the sine graph? So this one should be your sine, and then it's either at the part where sine, oh sorry, this is sine x. So sine x top down, yeah, correct. So it will be at the place where 90, so pi over 2. Okay, so same thing, try to solve it. So for this one, you should be able to get pi over 6. And the other one is quadrant 2. So using pi minus pi over 6 give you pi over 5 pi over 6. Then this one you have only 1, which is pi over 2. Okay, so if you want, then you can rewrite it in the complete form. So x equals to pi over 6 radian, then pi over 2 radian, and after that the last one is 5 pi over 6 radian. Alright, so same thing, you can just use your calculator to substitute everything to check, but make sure that when you check in your calculator, you are making it into radian form lah. So let us just like do it like quickly. Okay, so you have cos 2 multiply with, let us try to do the last one maybe, 5 pi over 6. Okay, so this is the multiply part. Then after that plus with 3 sine. Then after that 5 pi over 6. Oops, sorry, what did I press? 5 pi over 6 as well. Okay, so equal to 2. So you know that your answer should be correct. So you can try to substitute the other one for this question also. Okay, so let's go to the last question. Okay, last one, proving question. So I will try to start with the left hand side. So if you want to try out, then you can try it out with the right hand side. I think you should able to get it as well, because it seems like much more complicated, but it's just that maybe you will have some problem with the tangent cube here. Okay, so we start with the left hand side also. Okay, so this one will be equals to tangent 3x. So how can you actually expand tangent 3x? So you can always in a term that tangent 2x plus x. Okay, so you remember the tangent a plus b equals to what? Yeah, so you have tangent 2x. So this is the combination for the compound angle and the double angle. So tangent 2x plus tangent x, then divide by 1 minus tangent 2x and tangent x. And this is not the end yet, because you see you have a tangent 2x here. So what you need to do, you need to use the double angle. So 2 tangent x divided by 1 minus tangent square x plus tangent x. Same thing, over 1 minus, change it also for tangent 2x, Okay, tangent x. So now let's try to simplify and expand it. So equal to, okay, so what you can try to do is you can just bring up the whole thing for the so okay, it's okay if we do it step by step. 2 tangent x plus, so you want to combine them together, right? So that's why you should be multiply with tangent 1 minus tangent square x also. So that's why tangent x minus tangent cube. You see, this is how you got cube already. Divide by 1 minus tangent square x. Okay, so you are bringing up the whole thing here. So divide by, so you can try to do the 1 minus part. So 1 minus 2 tangent square x divide by 1 minus tangent square x. Okay, so you can simplify the first part that you have. So 3 tangent x minus tangent cube x divide by 1 minus tangent square x. Okay, so how about this part? So you can just simplify the 1 here first. So 1 minus tangent square x minus 2 tangent square x divide by 1 minus tangent square x. So this one you don't have anything that you can simplify anymore. So how about for the second part? So you need to change it to multiply, right? So you can just reverse them. So I mean upside down. Then after that you get 1 minus tangent square x divide by, when you minus you get 3. So 1 minus 3 tangent square x. So you can see 1 minus tangent square and 1 minus tangent square cancel out each other. So you left with 3 tangent x minus tangent cube x divide by 1 minus 3 tangent square x. I think this is a thing that we need to prove. Yeah, correct. So you get the exactly same thing. So this one is equals to your right hand side. So proof. Okay, so that's it for this question. But of course, I think for this part, right, if you know how to do the multiply for both sides, then you do not really need to bring this up. You get what I mean? So meaning that you just combine them together, then the whole thing you multiply by 1 minus tangent square x over 1 minus tangent square x. So you do not have like two terms here to deal with, but the idea is the same now. Okay, so that's it for the lesson for today. So just to I mean use your time, spend your time to finish off your exercise and so on. All right, thank you.